You can ship analyzer and mapping changes in OpenSearch with zero downtime if you reindex with shadow indexes and an alias swap. By the end, you will understand the simple pattern that keeps reads steady while you change how documents are analyzed and scored. I'm Professor Pi, teaching search and IR with simple Python. Zero downtime reindexing is a practical pattern, not an algorithm. Teams reach for it when they must change analyzers, mappings, or index settings without interrupting search. The pain it solves is real. Searches must stay live while you tweak stemming, tokenization, or field types. Success means users never see errors or stale routes, and relevance improvements roll out smoothly. At a high level, the idea is straightforward. Build a new index that implements your change. Backfill or dual write so new and old stay consistent. When the new index is ready, flip a stable alias to point at it in one atomic step. That swap is what gives you zero downtime. We will build a tiny, concrete demo that shows a baseline index, a shadow index with an English analyzer change, a backfill task, a short dual write check that shows score differences, a guarded alias swap, and final cleanup. This keeps the code friendly and the outcome visible before we scale it. This snippet creates a minimal working baseline in OpenSearch by indexing one document and attaching a friendly alias. The OpenSearch client connects to a local node with a simple host and port configuration. The variables IDX v1 and alias define the current index and the stable read name that applications can target. The client.index call writes a single document containing the title field, which will make later ranking differences easy to see. The client.indices.putAlias call binds the alias to the source index so consumers can read without hard-coding versioned names. Finally, the count on the alias confirms a live dataset. Seeing v1 count equals 1 verifies a ready baseline to evolve without downtime. Now, we create the shadow index and start copying data without blocking. This example prepares a shadow index in OpenSearch with an analyzer change, then backfills data asynchronously. The variable IDXv2 names the new target, and M declares a mapping where the title field uses the built-in English analyzer for stemming. The client.indices.create call builds the v2 index with that mapping, keeping v1 untouched. The client.reindex function copies documents from IDX v1 to IDX v2 and wait for completion false, starts the work without blocking the caller. That choice keeps your process responsive but requires monitoring the task for completion later. The printed task identifier confirms the backfill is in flight and traceable. Next, keep writes safe by duplicating new documents to both indexes while the backfill runs. This code demonstrates dual write during migration and a measurable scoring change between indexes. The variable d2 holds a new document that is written to both IDX v1 and IDX v2, so no traffic is lost while backfilling. The refresh loop makes the new writes visible to search immediately. The client.search calls query each index with the same text, returning the best hit from each. The variable delta subtracts the v1 top score from the v2 top score, showing how the English analyzer can shift ranking strength. Increasing query specificity usually raises absolute scores and can widen this gap. A non-zero score delta indicates the analyzer change materially affects relevance. Then verify health and parity and flip the alias in one atomic call when ready. This snippet performs a guarded cutover in OpenSearch using a small checklist and a single atomic alias update. The variable 8 captures cluster health while waiting for at least yellow, ensuring replicas are not mandatory for proceed. The variables C1 and C2 count documents in IDX v1 and IDX v2 to verify backfill completeness. The Boolean ready encodes both health and parity, preventing a risky flip. The dictionary Ax defines a remove and add sequence for indices.update aliases, which atomically moves the alias from v1 to v2, so clients switch without downtime. Printing swapped equals true signals the alias now points at the shadow index safely. Finally, restore normal indexing settings, remove the old index, and confirm reads hit the new index. This code finalizes the migration by restoring freshness settings, cleaning up, and confirming reads route through the alias. The client.indices.put settings call sets refresh interval back to 1 second on IDX v2, balancing ingestion overhead with timely visibility. Removing IDX v1 with client.indices.delete prevents stale reads, frees space, and reduces operational confusion. The variable R issues a quick search against alias, now bound to v2, and T extracts the title of the top match as an end-to-end sanity check. If higher write throughput is expected, a slightly larger refresh interval can reduce indexing cost. Seeing alias top confirm real content means cutover completed cleanly. In a real project, this toy flow maps directly. The initial index is your live data. The shadow index is your staging space for analyzer or mapping experiments. The reindex task scales to larger data by running on the cluster. Dual write can be routed through your application or an ingester. The alias swap stays the same, whether you manage 100 documents or 100 million. Recap: zero-downtime reindexing builds a shadow index, backfills or dual writes, then atomically swaps an alias. Use it when you must change analyzers, mappings, or other index-level settings without interrupting search. Caveat: you must monitor reindex tasks and verify document parity before the swap. Next step: measure and tune the refresh interval and indexing throughput for IDX v2 while running a real dataset to balance latency and cost. If practical, hands-on IR helps. Subscribe and watch the IR videos.